Good morning, dear students, and welcome to today's session. Take a look at this wrestler. He's training very hard. His training routine includes exercising, working out in the gym, cycling, jogging, swimming, and wrestling. He aims to represent India in Asian Games. Doing this sort of hard work definitely requires energy. But where does he get the energy to do all these kind of activities? It's obvious from the food he eats. But where does the food get the energy from? In this session, we shall learn how to define energy scientifically. What are the different forms of energy and what is the relationship between energy and work? So let's begin. All living beings need to carry out certain essential activities called the life processes. In order to survive, these processes require energy which basically comes from the food they consume. Even machines require energy for their operation. For instance, gadgets like television, mobile, refrigerator, etc. work using electrical energy. But what is the scientific definition of energy? To understand this, let us consider some daily life examples. When we hammer a nail onto a wood, the nail is driven inside the wood. In garages, when the mechanics wash the car, water at high pressure is used to clear the dirt and dust on the vehicles. In all these examples, we notice that work is done by these objects. This ability to do work is what is called energy. The object which does the work loses energy, and the object on which the work is done gains energy. For example, while hitting a nail with a hammer, the person hitting the hammer loses energy, while the nail that goes into the wood gains energy. Here, the energy is transferred from a person to the hammer and from the hammer to the nail. The person has the capability to do work and hence possesses energy. The SI unit of energy is joule. The same as that of a work done. So 1 joule is defined as the energy required to do work, which is 1 joule of work. Sometimes a larger unit of energy called kilojoule is used. So 1 kilojoule is equals to 1000 joules. The unit of energy and work is named after a British physicist, James Prescott Joule, in the recognition of his work on heat energy and the law of conservation of energy. Now, have you wondered where do we get the energy from? We get the energy from different sources in different forms. Let us look around us and try to identify which are these different forms of energy. Now, the sun is the biggest natural source of energy on the earth. Energy from the sun is in the form of heat and light energy. Most other sources of energy are directly or indirectly derived from the sun. For example, plants prepare and store food using the energy from the sun. The stored food is consumed by animals and human beings. The energy that is released is used to do work by a chemical reaction known as chemical energy. Energy consumed by electrical appliances such as bulb, TV, radio, iron box, etc. is electrical energy. And electrical energy is due to flow of electric charges. When we hammer a nail, the type of energy that drives the nail into the wood is a mechanical energy. And mechanical energy is classified into 2 types: potential energy and kinetic energy. Energy possessed by an object by the virtue of its position is called potential energy. For example, if I raise this pen from a certain height from a table, it will have potential energy. This is because work is done against gravity while holding it at a certain height. Energy possessed by the body due to its motion is called kinetic energy. Now, all the moving bodies possesses kinetic energy. For example, flowing water can carry objects such as paper boats, leaves of trees, mud, etc. along with it. Floods even carry animals, human beings, houses, vehicles along with them. This is because moving objects carry energy. Wind also carries energy. Wind carries dry leaves of trees and mud along with it. All these examples indicate that moving object possesses energy. Let us now derive a mathematical formula for kinetic energy using equations of motion. The equation of motion connecting the initial velocity u and the final velocity v of an object moving with a uniform acceleration a and the displacement s is v square minus u square equals to 2as. Rearranging the equation, we get s equals to v square minus u square divided by 2a. This is equation number 2. From Newton's second law, we have F equals to ma. Call it equation number 3. Work done is given by W equals to F times S. Call this equation number 4. Now using the equation 2 and 3 and substituting them in 4, we get W equals to ma times v square minus u square divided by 2a, or W equals to m times v square minus u square divided by 2. This is after cancelling a. If the object was initially at rest, then its initial velocity, which is u, is equals to 0. Then the above equation reduces to W equals to mv square divided by 2. Thus, the kinetic energy possessed by an object of mass m moving with a uniform velocity v is Ek equals to mv square divided by 2. From this formula, it is clear that the kinetic energy of a body is directly proportional to the mass of the body. Therefore, if the mass of the body is doubled, then the kinetic energy will also get doubled. And if the mass of the body is halved, then the kinetic energy also gets halved. Kinetic energy of the body is directly proportional to the square of the velocity of the body. Thus, if the velocity of the body is doubled, then its kinetic energy becomes 4 times. And if the velocity of the body is halved, then its kinetic energy becomes 1/4. Let us now solve some numerical example based on kinetic energy. A vehicle is traveling at a velocity of 10 meters per second and it has a mass of 250 kg. Calculate its kinetic energy. Mass of the body m is equals to 250 kg. Velocity v is equals to 10 meters per second. We already know that the kinetic energy of a body, Ek, which is equals to mv square divided by 2. This is equals to 250 times 10 times 10 divided by 2. And we get the result, which is equals to 2500 divided by 2, and this is equals to 1250. So the kinetic energy of the vehicle is about 1250 joules. Two bodies of equal masses move with uniform velocities 2v and v respectively. Calculate the ratio of their kinetic energies. In the question, it is given that the masses of the two bodies are equal. So let the mass of each body be equals to m. We will now write down the expression for kinetic energy of both the bodies separately. Mass of the first body is equals to m. Velocity of the first body, which is equals to 2v. Kinetic energy of the first body is equals to half m 2v square, which is equals to 2mv square. Mass of the second body is equals to m. Velocity of the second body is equals to v. Kinetic energy of the second body is equals to half mv square. Let's keep this as equation number 2. Now, to find out the ratio of the kinetic energies of the two bodies, we have to divide the equation 1 by equation 2. So, kinetic energy of the first body divided by the kinetic energy of the second body, which is equals to 2mv square divided by half mv square, which is equals to 4 by 1. Thus, the ratio of the kinetic energy are in the ratio which is 4:1. Now, we have come to the end of this session. Let us now do a quick recap. Energy is defined as the capability to do work. The unit of energy is joule. 1 joule is defined as the energy required to do 1 joule of work. Some form of energy are heat, light, electrical, chemical, kinetic, and potential. Kinetic energy and potential energy are two forms of mechanical energy. The energy possessed by an object due to its motion is called kinetic energy and is given by Ek equals to mv square divided by 2. In our next video, we will discuss potential energy and the law of conservation of energy. So keep watching RankPedia for more such fun videos.